Good morning, Nana. Shivadanesh, Ritan, Chinmayi. Inform to your friends, Nana. Most important topics are going on. If you don't want to, all our mains level questions and advanced level questions. Manvita, Saiti, Chinmayi, Himagna, where is Himagna? Chandrahas, Ashwit, Sherwani. Inform to your friends, Nana. We'll do some most important topics on today. So yesterday we started geometrical applications. There are endpoints in a plane, exactly P of them are collinear, then the number of straight lines that can be formed by using these endpoints is NC2 minus PC2 plus 1. Okay. Out of endpoints, we are selecting for lines. For two lines, we need 2 points for making a straight line. Then out of endpoints, we can selection is NC2. Okay, Rishabh. There are endpoints in a plane, exactly P of them are collinear, then the number of straight lines that can be formed by using these endpoints. Yesterday we learned that is NC2 minus PC2 plus 1. So to form a line, we need 2 points. Then out of endpoints, we are selecting that is NC2, in which P of the points are, P of them are collinear. So we have to subtract from these lines. So minus PC2 plus 1 means that points is overlapping from endpoints and P points. So that should be adding the number out of these points. Okay, NC2 minus PC2 plus 1. And the second formula we have learned in the yesterday geometrical applications. First formula is NC2 minus PC2 plus 1. Okay, this is the number of ways of endpoints in a plane. Exactly P of them are collinear, then the number of straight lines that can be formed by using these endpoints is NC2 minus PC2 plus 1. Next one, there are endpoints. There are endpoints in a plane, P of them are which are collinear. Then for that number of triangles that can be formed is second formula with yesterday we learned, that is NC3 minus PC3. So number of triangles that can be formed by out of endpoints P, when P of them are collinear. Next third formula we learn, that is out of M parallel lines intersected by the another set N parallel lines, then the number of parallelograms is nothing but MC2 into MC2 points. Next fourth points are MC2 into NC2 number of parallelograms we can get. Next fourth point is yesterday we learned, that is fresh lines That is, there are n lines in a plane, no two are parallel and no three are concurrent. New lines are formed by joining the points of intersection of these points. Then the new lines that can be formed is n into n minus 1 into n minus 2 into n minus 3 divided by 8. Divided by 8. Okay, that is the fresh lines formula. These four lines, these four concepts yesterday we learned. From this basis of these formulas, next some points on advanced level questions. So we'll do Ashwit Presenta, Chandrahas, Rakesh, what about the remaining Nana? Himagna, Sherwani, call to Himagna. What happened? Okay, geometrical applications based on this form concepts. Okay, that the formula first question. Question number 1, most important topics. Lines L1 and L2 are parallel to each other. Three points are taken on L1 and 4 points on are taken on L2. How many new straight lines can be drawn passing through these points? Geometrical representation of a applications, these basic concept problem only. Okay, line L1 and L2 are parallel to each other. 3 points are taken on L1 and 4 points are taken on L2. How many new straight lines can be drawn passing through these points? Okay, how many Nana? Give the response. Very basic question this is. Very basic question. This is line L1, this is line L2. From this, there are how many points on L1? 3 points are L1, that is point P1, point P2, point P3, and there are 4 points on line L2. There are P4, P5, P6, P7. Okay. Then find out how many straight lines can be drawn passing through these points. They are asking. How many lines, Lana? Hashwit, Chinmayi, Rahiti? How many lines can we draw out of these points? Shivadanesh, Sritam, Manvita. Okay. So out of we need here 3 points are there and this is 4 points are there. Then we need, this is possible if we are get by only out of 3 points, we can select one point on L1. This can be done in the form of 3C1 ways for first line. And second line, out of 4 points, to form a straight line for this by joining on the line L1 and a new lines they are asking. That is why if you want to make a point on L1, we have to select, and second one is must be select from out of 4 points on L2. So then only we can join, like these points will come. This type of straight line, how many can draw passing these 3 points? So out of second line we can select, out of 4 points we can select as 4C1. Therefore number of ways, that is new lines to be drawn passing through these points is 3C1 into 4C1, that is obviously 12. Very basic question, but question is thinking this is so much lengthy, but in the asking the question is new straight line, that should be possible. That is possible if we are get by only out of 3, then we can select 1 point on L1, then that is the case as 3C1. And then second, out of 4 points we can select from 1 point on L2, then it can be done in 4C1 ways. Therefore total ways equal to 12. That's all. This is the simple question. But the question number 2. The side ABBCCA of a triangle ABC have 3, 4, 5 interior points respectively on them. How many triangles can be drawn constructed using these interior points as vertices? Don't go elsewhere, Nana. So many people are leaving. What happened? Question number 2. The sides AB, BC, CA of a triangle ABC have 3, 4, 5 interior points respectively on them. How many triangles can be drawn, constructed using these interior points as vertices? So what are the values we have? We construct one triangle, then get an eye for our convenience, draw a, but logically thinking, then we get the answer very easily. Okay, then the triangle obviously ABC. So the side ABC, BC, CA of a triangle ABC have how many points on them? So that is 3 points on AB. That is point P1, P2 and then P3. Next 4 points are there. BC 1, 2, 3, 4. That is Q1, Q2, Q3, Q4. Next 5 points are there. R1, R1, R2, R3, R4 and then R5. Okay. The sides AB, BC, CA of a triangle ABC has 3, 4, 5 interior points respectively on them. How many triangles can be drawn constructed using these interior points as vertices? So let us take, suppose P1, P2 by joining these points. This is one way, and this is to be second way, these points, and this is to be taking these 2 points can be the so many triangles we can construct, but is how many triangles we are unknown. So we need, that is why we can select the wrong ways, nothing but taking the collinear points and the easy ways to solve this problem. We need 3 points from any sides of the triangle, but no number of cases will be more. So that is to write, we need to form another case. Logically we can think, that is we need construct a triangle, we need just for 3 points is enough. But number of cases will be more for this solving this problem. That's why we think need to form another way. We can wrong ways we can select, but nothing but collinear case points we can, the case is only the wrong way. So we need to form a total ways of selecting to form a triangle minus wrong ways we can do. So we taking any 2 point on this or on this, so many will, number of cases will, so many will come. So the number of will, more cases will we have to get. But we need to form a number of cases, nothing but easily forward thinking, easily total number of ways of selecting to form a triangle minus number of cases are more. That is why we are thinking another way. Number of cases will be more. So that is why we are doing like this. That is total number of ways of selecting to form a triangle minus wrong ways. Wrong ways nothing but which cannot be form a triangle ways. That is meaning if you want take any 3 points, if it is collinear we cannot construct a triangle. That is the wrong way. Similarly, out of AB side, BC side, CS side we can. Okay, we can do like that only. Total number of ways of selecting to form a triangle minus wrong ways. Wrong ways nothing but collinear points. If you are getting 3 points, we can construct a triangle. Any non-collinear points, we can construct a triangle. Otherwise, if it is 3 points, it is collinear, we cannot construct a triangle. Such type of conditions are said to be wrong ways. Total number of ways of selecting it to form a triangle minus wrong ways, nothing but collinear cases. Okay, that is why we can easily solve this problem. Okay, wrong ways. How many total number of ways? That nothing but here we have 3 points, here we have 4 points, here we have 5 points. Out of 3 plus 4 plus 5 nothing but 3 plus 4 plus 5, that is nothing but 12 points are there. To form a triangle we need, from this form a triangle we need 3 points is enough. So that is selection out of 12 points we are doing taking selection from 12C3 minus, so now wrong way is nothing but collinear. Out of 3 points, out of 3 points, we taking this out of 3 points at a way, at a stretch. That is 3C1 means we can construct a triangle. 3C2 means also we can construct a triangle. If it is, we are selecting at a time out of 3, we are selecting 3, we cannot form a triangle. That means it is as it to a collinear. Then P1, P2, P3 becomes collinear. Then we cannot construct a triangle. That is why as out of 3 points, I am taking collinear points as in the form of 3C3 ways. And next one, in the other way case, out of second side. Second side means how many points are BC side? We have 4 points are there. So out of 4 points, we can suppose we can select 4C1. Then we can construct a triangle. And then if we were selecting out of 2 points, also we can construct a triangle. So if it is, it cannot be as taking a selection from out of 4C3 points. 4C3 means we cannot construct a triangle. And similarly, out of 5 points, we select any 2 points, we cannot construct a triangle. That is why this is the wrong ways of, that is meaning that these are all collinear cases, collinear points cases. So out of form a triangle, that is 12C3 minus wrong ways nothing but collinear cases. Collinear points cases nothing but from the side of AB. At a time, out of 3 points, we can take the 3 points to form a straight line. We can get a straight line. That is meaning that the points lying on the same line, then does not form a triangle if it is the points lying on the same line. Similarly, BC side we can take 4C3 pi. Out of 4 points, we can take 3 points. We cannot construct a triangle. And out of 5 points, if you are taking at a time 3 points, again it doesn't form a triangle. That is why these points are said to be collinear case or wrong bases. Wrong bases are 3C3, 4C3, 5C3. Then total value becomes 12C3 nothing but 12 into 11 into 10 divided by 3 into 2 into 1 minus 3C3 nothing but NCN. NCN nothing but 1. 4C3 nothing but NCR equal to LCN minus R. That is 4C3 nothing but 4C1. 4C1 is 4 and 5C3 nothing but 5 into 5C2. 5 into 4 by 2 into 1. That is obviously 10. So that is equal to 2 ones, 2 fives, 3 ones, 3 fours. So 55 into 4 we can get 220 minus 15. There is total value becomes 205 triangles we can construct if it is a triangle having AB, BC, CA respectively 3, 4, 5 points on them. Okay, understood? The logic we have to pick up. So total number of cases we are getting so many cases. So thinking this is the way of total we need to form a total ways of selecting form a triangle minus wrong ways. Wrong ways mean nothing but the collinear points case. So how many we are getting collinear with by using the 3 points, 4 points and 5 points. Then we get 3C3 plus 4C3 plus 5C3. Then you get the remaining sides are to be interior points as what is said. We can draw a constructed triangles. Totally we can get 205 triangles. Okay. This is the one way of approach. This approach we can usually directly we can use simplify the problems on your own. Okay. Same thing as to question number 3. Nana, are you getting or not? Give the response, Nana, once again. Rishabh, Ritan, Shivadanesh, Anirudh, Shravani, Sharvani, Sahiti, Manvita, Chinmayi, Shivadanesh, Ashwit, Prajanta. Okay. Next question number 3. The maximum point of intersection of n circles and m straight lines among themselves is 80. Then find the value of n is dash. These are all advanced level questions, Nana. The maximum points of intersections of n circles and n straight lines among themselves is 80. Then value of n is, then n equal to dash. The maximum point of intersection of n circles and n straight lines among themselves is 80. Then what with the value for n for giving point of intersection of out of selecting the value maximum by n circles and n straight lines. Suppose if you are taking 2 points and 2 circles, we get less amount of values. So we think as to this is another approach you can solve. These cases point of intersection can be formed by unique and special cases of combination. So we can expect the different types of cases, then we can get the answer value of n. So that is the exceptional cases only we can think how to get the answer. The maximum points of intersection of n circles and in straight lines among themselves is 80. Total answer is given 80. But how many point of intersection getting in how many circles get the point of intersection and straight lines? Then the value of n, for what value of n it becomes to 80 they are asking. So this type of questions, another approach, Nana, like that, this type of questions. The approach is different. We have to think different exceptional cases. We have to select. The point of intersection can be formed by different cases. We have to arrange. We have to select. So the cases I am taking case 1 and then case 2. How many cases we can arrange? And then suppose let it be case 3. For getting maximum they are giving. So we have to get maximum points of intersection to form a n circles and n straight lines are. So let it be 2 lines we have to select. Out of 2 lines, the point of intersection can be formed by maximum number of point of intersections. And the second case is if you are taking 2 circles at a time, then we can number of maximum point of intersections. This is the another exceptional case. And third case is we have to select one line and one circle. Then we get the maximum point of intersection. If suppose 2 lines we can get, how many point of intersection we can get? Only one point of intersection. If it is 2 circles, the point of intersection of both 2 circles, the point of intersections are 2 point of intersections we can get. And one line and another one line and one circle, then also we can get as how many ways of point of intersection we can get? Nothing but one line and one circle. How many? If we draw anyway, but we have to get only 2 point of intersections. 2 point of intersection. This is the maximum point of different exception cases. By taking the number case 1 is if you are taking 2 lines, we get maximum point of intersections. And if you are taking the at a time as 2 circles, also we can get the 2 point of intersection. And then one line and one circle out of n circles, but just we are taking exceptional cases. For this can be formed by special cases of combination. So we can expect by following cases. So out of n points, we can take any 2 lines. This can be done in maximum NC2. How many we can get? This how many out of n similar circles are how many n points? Just we are taking the 2 lines, nothing but we need 2 points as in the form of NC2 lines. We get this type of how many 2 lines we can get? Only 1 point of intersection. This is the first point of intersection case. And then second case, by taking out of n points, then we are selecting any 2 circles. In how many cases? That is nothing but in C2. How many point of intersection we can get? Maximum is only 2. Similarly, the one line and one circle we can take. Out of n points, one line can get in C1 and another one circle we can take. Also we can get as number of is in C1. How many point of intersection maximum we can get as 2 only. Okay, such exceptional cases we can take. Therefore, the value is NC2 plus NC2 plus NC2 into 2 into plus NC1 into NC1, that is N square, 2 into N square, equal to, given that in the question is given 80 is given. So make it to equal to 80. So 2 into NC2 becomes 2, 3 times of NC2 plus 2N square minus 80 equal to 0. Then by solving these cases, that is 3 times of NC2 nothing but 3 into NC2 is n into n minus 1 by 2 factorial plus 2n square minus 80 equal to 0. From this, to taking 2 LCM, 2 to the 4n square, here n square 3. So totally we can get 7n square minus 3n minus 160 equal to 0. Then solving the factoration, minus 35n plus 32n minus 160 equal to 0. Therefore, we can get from this 5 common, this is 5 common, then n equal to 5. That's all. By doing the simplification, we can get number of circles, maximum point of intersection of n circles, that is 5 circles and 5 straight lines among themselves is becomes to 80 point of intersections we can get. So the possible cases are, if you want to take exceptional cases, we have to think such type of questions are there. We have to observe the number of cases. How do we get that? The logic thinking. Okay. Don't take the total value maximum points of intersection out of NP. Don't think like that. So number of subcases, how many subcases can we find? So we have to think, that is the logical thinking. Then to suppose we are taking two lines, the maximum point of intersection is only one case, and the two circles if we take only maximum two point of intersections, and one line and one circle. Such type of cases you can take. So different combinations, either two circles or lines, or else one line and one circle. Then only we can get the values of number of values of different points of intersection, that is to be maximum. Okay, this type of questions are there in the advanced level. Next, go to the next question. Chinmayi, Manvita, Sahiti, are you getting, Nana? Ravani, Sharvani, Sritan, Shivadanesh, Rishabh, Hashvir. This type of questions are in the advanced level. Okay, next we'll go to the next question. Question number 4. There are 11 points on a plane, of which 5 are concyclic. Other than this, no other 4 points are concyclic. Find the maximum number of circles that can be drawn so that contains at least 3 of them given point C is dash. There are 11 points on a plane, of which 5 are concyclic. Other than these, no other 4 points are concyclic. Then find the maximum number of circles that can be drawn so that contains at least 3 of the given points is dash. There are 11 points on a plane, of which 5 are concyclic. Other than these, no other 4 points are concyclic. The maximum number of circles that can be drawn so that contains at least 3 of them given points is dash. So, what is mean by first of all concyclic? Concyclic means you have to know first. Concyclic means the set of points lying on the given quadrilateral or given circle. If it is a quadrilateral or anything, triangle or anything, it is lies on the triangular quadrilateral, then it is said to be concyclic. So if non-collinear cannot form a circumcircle. So first non-collinear points only can form a circumcircle. So we have to suppose 3 points are there, then we can form a triangle and it is also concyclic. That is meaning that out of the 3 points, it is passing through the three vertices of a triangle. Then it is said to be circumcircle as well as concyclic. Concyclic means the points lying on the given figure, that is maybe triangular, quadrangle, anything. But in the question it is given, if there are 11 points on a plane of which 5 are concyclic, other than this no other 4 points are concyclic, then find the maximum number of circles that can be drawn so that contains at least 3 points of the given point is. So let us, we can observe the value by taking rough diagram, but it is rough diagram only, but our convenience. So number of circles they are asking, let us we construct one circle. How many points on them? That is 1, how many are there? 11 points, but 5 are concyclic. So concyclic means these points to be, it is lies on the circle 1, 2, 3, 4, 5. These are concyclic. How many points? Totally 5 points are concyclic. That is why 5 points are concyclic means we have taken on the circles on the circle. Okay. Next, how many remaining? Out of 11 points on the plane, 5 are remain. Then we have to remaining the points are to be. How many points? Let it be 6 points. Let it be how many non-collinear or collinear we cannot take. It is the remaining, how many are there? 6. 6 points are there. Total 11, 5 is concyclic, another is non. If it is concyclic or non-concyclic, another issue. But the number of circles that can be drawn so that contains at least 3 of them in the given points. So number of cases we have to select. So the unique choices you have to select, that is out of from the 5 points we have to selection, and then from the circle we have to choose the number of choices, and the remaining the points out of 6 points we have to select the non-collinear points. So we can the different types of choices we have to observe. Then the circle, unique circle, 3 points are necessary. So therefore we have to select number of different cases. Suppose circle form, in the circle form let us take a out of how many points we have? 5 points are there. And the next one, non-collinear point, let us think as to non-concyclic or non-collinear point. How many are there? 6 points are there. So to form a circles can be that it is the becomes to be triangles or concyclic points. That is why we have to select different concepts. So this can be done in, let us to be taking out of these circle points as, suppose let us we can observe any 2 points we can take out of these 2 points and 1 point of this value, then we can construct a concyclic. From this we can draw a concyclic points. This type of question. Okay. So one of the case it is must be non-collinear points we can take as circles in the points as uh, two cases or three cases. Or another way is and take the another form also we have to observe. Like that possible cases we have to choose. Suppose non-collinear out of these points we can select any 3 points. Any 3 points. Here we can get to form a triangle means we have to select 3 points is enough. That is why I am taking 3 here. Then we can get here as to 0. And the next case is to be out of this we can select any 2 points and one of the point on this points. Totally then we suppose like this we can construct. Therefore we can draw a number of concyclic points. So then we can select out of these 2 points and here 1 point we can select. And then remaining here 1 point and then we can take as to 2 points. Here we can take 0 points non-collinear point and the circle also cannot be circles cannot be done. Why? Because already it can be remained number of cases. So this is not a unique way. Take only the value. Suppose you can this type of method already we taken. So common circle points we can take. That is why should not be take as to this is as to 0. So 5 is not coming. So total arrangements is out of 6 strings we can select any 3 points is 63 and next out of these points is 5C0 nothing but into 1. Next one out of 6 point we can select only 6C2 and into 5C1 and next 6C1 into 5C2 and the last way is 6C0. So that is 63 nothing but we can select 6 into 5 into 4 by 3 into 2 into 1 that is 20 plus 6C2 nothing but 6 into 5 by 2 into 1 that is 5 3 is 15 into 5 plus 6C1 nothing but 6 5 into 4 by 2 into 1 this is 2. So 6 into 10 that is 60 60 is 1 20 plus 7 15 5 is 75 plus 60 plus 1. So the total value we can get how many 5 plus 1 6 6 plus 7 13 156 156 circles can be drawn so that the contents at least 3 of them are given points. Okay, this is the question number 4. Different types of problems are Nana. Next go to the another concept we can be it as AP. Heading as AP geometrical problems is like this. Then go to the next concept as AP problems. AP means arithmetic progression. Arithmetic progression. So such type of questions we can take. The previous year question, Nana, this is the type of different type. The number of ways of selecting 3 numbers from the first 2n natural numbers which are in AP. The question is like this. The number of ways of selecting the number of ways of selecting 3 numbers from the first 2n natural numbers which are in AP. is dash. So the number of ways of selecting three numbers from the first two n natural numbers which are in AP. So if it is in the terms of in AP, suppose let it be take it as A comma B comma C are in AP, then the formula is what? 2B equal to A plus C. This is a basic idea. If the points are in the term form of AP, okay. So now we have to write if A comma B comma C are in AP, then the condition we have to write as 2B equal to A plus C. Whether B is even or odd, then we have to think 2B is what? If it is B is even or odd, 2B is always what is? If we are taking B as even or odd, 2B is always even. Similarly, this part LHS is even nothing but A plus is also even only. Okay. Whether B is even or odd, 2B must be always what? Always is even only. If term suppose we have taken as odd number or even number, 2B is always carries you even number. That implies A plus C is always is even. Therefore, what is the question? Selection of three numbers to form the first two NHL which are in AP. AP means the terms in the form of three terms we have to select them. Okay, we total ways we have to select, but selection of three things, three numbers. The series must be in form of AP series. Number of how many cases we can select. That is the question. So, select two numbers so that the sum of the two numbers is always even. They always form an AP with a fixed number. AP means the common difference should be same. The fixed number will be always same in the each and every two numbers. So here the sum of the two numbers is must be even nothing but in how many possible cases we can get if both numbers are even or else both numbers are odd. Then only the sum of the even must be even. Okay. That is if the total number of 2n numbers sub cases is what? Both are even or both are odd. Then only then the two numbers must be even. This is the possible cases. So out of the question is given in the out of first 2n numbers is given. So that is why out of 2n numbers, how many cases are there? Both are n must be here and here n. So both are n of compulsorily it should be as even or else it is as to be odd. The cases from these two numbers we can select. This can be possible if in C2. From these odd numbers we select two numbers. This is also possible cases in C2. Therefore, the total number of ways is equal to 2 times of NC2 plus NC2. That is 2 times of NC2. So that is 2 into n plus 1 by 2. 2 cancel which carries you n into n plus 1. That is the number of ways of selection of three numbers from the out of 2n natural numbers which are in AP. Okay, this type of another question I'll give you. Okay, question number 2. The number of ways of selecting three numbers from the first 2n plus 1 natural numbers which are in AP. The numbers of ways of selecting three numbers from the first 2n plus 1 natural numbers which are in AP. In previous problem, only 2n numbers are given, but here we have to select the 3 numbers, but it is in the form of AP. But first we have to select only for 2n plus 1 numbers. 2n plus 1 numbers means odd numbers. The case is what? If one of the case is if both numbers are even, or else odd. Second case is odd. So select from these two numbers in NC2 ways, and odd numbers from select to two numbers, then it is to be two ways. Therefore, out of 2n plus 1 numbers, 2n plus 1 numbers, 2n plus 1 nothing but odd. So the cases must be 2n, and here it should be n plus 1. This is must be even, and this must be odd only, then it will be get the correct. From this we have to select two number selection, that is how many ways? In C2 ways. From these odd numbers we can select two numbers, then we can select as n plus 1 C2. Therefore the total answer is not 156 Nana. The total answer is therefore NC2 plus n plus 1 C2. NC2 is n into n minus 1 by 2, and then n plus 1 into n minus 1 by 2. So n into n minus 1 here. So by simplification, then the answer is like this only. The question is given. By our simplification, you can do yourself. This is the question number 2 way. And the same thing, previous year question is there, Nana. Question number 3. How many 3-digit numbers? How many 3-digit numbers can be formed such that its digits are in increasing AP. The digits are in increasing in AP. So we have to how many numbers, that is 3-digit numbers will be compulsory, can be formed such that its digits are in increasing of value. Let us take any values of series AP, means the common difference must be same, but it is in the form increasing level. Suppose you can take 256, 147 like this only. Don't take the smaller to big numbers. Increasing order should be there. So we have to select how many numbers, ABC numbers. In these, we can formula is 2b equal to a plus c. Then this should be in increasing in AP. Increasing in AP. Just now we have learned the case 1 is what? The case 1 is what? And the case 2 is, then we can get the values very easily answer this type of question. If the two numbers must be, or if A and C must be, suppose the case between A and C, both are odd, then only we can get even. First case. If it is case 2 is there, if A and C both are even, first you take. For our convenience, both should be even, the summation is even, then 2b also it will be even. Both will be even, and A and C both are odd. Then only the numbers we can get AP, summation should be even, that is 2b also even, always 2b even. So 3-digit numbers we have to take, both should be even. So even means What we can get even numbers means how many we can 3-digit number. Maximum even numbers will be there as how many numbers will get 4. Even numbers means 2, 4, 6, 8. Out of 4 numbers, we have to select both the numbers as in how many numbers? 2 numbers. So this can be done in how many ways? 4C2 ways. Similarly, if both numbers are 2 numbers, we have to select that should be odd numbers. Odd numbers means what? 1, comma 3, comma 5, comma 7, comma 9. From these, we can select 5C2 numbers. Then it is 5 into 4 by 2 into 1. Then it is 10. Here we can get 4 into 3 by 2 into 1. 6. Therefore, total number of ways that is equal to 10 plus 6. That is 16 ways we can get. So this is the way of writing the question for solving the 860. Similarly, one more question is there, you have to practice. Then go to the another concept. Question number I'll give you, do yourself. The number of ways of selecting 4 numbers from the first 50 natural numbers which are in AP. Which are in AP. This type of question is there. Okay. This is the AP problems. This type of questions. AP problems. Next we will do the next concept. The number of ways of selecting all things from n distinct things is always denoted by NCR. We know that formula. That is, what is the formula? The number of ways of selecting all things from n distinct things or different things is denoted by NCR. Same thing as if it is the number of things are selecting odd thing from n identical things, then what is the answer? The number of ways of selecting odd things, if it is n different things, is denoted by NCR. But the number of ways of selecting odd things from n identical things is how many ways? How many ways can we select? The question is the number of ways of selecting are things from n identical, similar, here distinct, here identical, n identical things is dash. How many ways, Nana? Identical things we have to select in how many ways? Ashwit, Shivadanesh, Akhilesh, Sarvani, Ritan, Shivadanesh, Chinmayi, Sahiti, Rishabh. If it is n identical things are there, we can select in only in one way. All are similar. All are similar means we can take only in one way we can select. Okay, this is the concept. Then go to the next heading, the total combinations of the n distinct things. The total combinations of the n distinct things. Total combinations of total number of combinations. Total number of combinations. Total number of combinations. So that is meaning that the total number of combinations means we can select either 0 things or 1 thing or 2 things or 3 things or 4 things or all of the things out of n things. So for each thing there are how many possibilities? Two possibilities. What are they? Are selecting or not selecting. That means rejection. Therefore, how many ways? Two conditions are there. Two possibilities are there. Therefore, we are selecting out of n distinct things. Then it is becomes 2. The total number of things are 2 power n. That is the formula. First formula is the total number of combination means total number of combinations means we can select 0 thing or 1 thing or 2 things, comma 3 things, so on, all things out of n things. For each thing there are two possibilities. Each thing can be two possibilities. What are these two possibilities? If the two possibilities nothing but if we are select or rejection. Selection or rejection. The two possibilities are there if it is a selection or else rejection. Therefore, the total number of combinations, the total number of combinations of the indistinct things is 2 to the power of n. This is the formula. So the total number of combinations are 2 to the power of n. That is out of n distinct things is can be possible two possibilities either selection or rejection. If you are doing selection that is NCR or NC1, NC0, NC1, NC2, NC3 so on NCL. If it is rejection means 0 ways, no ways. So how many ways totally we have? 2 to the power of n. That means we are selecting out of n things. Selection is NC0 or taking NC1. are taking two things, are taking three things, are taking n things. Okay. R means what is the formula? NC0 plus. If it is and, we have to multiply. If it is R means NC0, NC1, NC2 plus NC3 plus so on up to NCN. How many possibilities just now we learned? 2 power n. This is the most important formula. The total number of combinations of n distinct things is always 2 to the power of n. That is, distinct things means 2 power n. Okay. Next, last formula. The total combinations of n identical, how many we can get? If it is total number of selections, these are C means combinations of selection. But here the number of the total combinations of n identical things. N identical things is dash. That means rejection. It doesn't like a zero selection only. So that is zero selection out of only one way. If it is things are only one, we can select only one way. If it is two things are there, we can select is one way. If it is three are there, we can select is only identical means only one way. Four things are there only in one way. In similarly, how many things are there? N maximum. This is also can be selecting only one way. That is means to be rejection. Rejection means always n. How many things are there totally? N up to this n, 0 is included. Then the value goes to, the value becomes to number of ways of selection of n identical things. Total number of identical things is n plus 1. Therefore, the total things equal to, total number of things equal to, this is things, this is selection or identical things. Identical things all are same. All are same means it can be possible in only in one way. So how many things are there totally means up to here n, 0 is included. The number of ways of combinations, total combinations are how many? N plus 1 things. Therefore n identical things only in possible only n plus 1. Okay, these are the total number of possible. Next, third formula. The total number of combinations P plus Q things taken one or more time at a time when P things are alike, Q things are alike, and next second, third kind is so many kinds are will be there. Okay, the total number of combinations of P plus Q things taken any number of at a time when P things are alike of one kind, Q things are alike of one kind, and three odd things are collecting or third kind, then it is to be selection is P plus 1 into Q plus 1. The number of the total number of combinations of P plus Q things taken any number of time when P things are alike Q things are alike is P plus 1 into Q plus 1. That means since any number of things can be selected from P plus Q things, the combinations may contain any number of things from 0 to P plus Q things. 0 to P plus Q things. So, of the first kind P are alike. So 0, none. 1, 2, 3, so on up to P things may be selected. Therefore, the first kind of things may be selected as, how many first kind we can select it as? P plus 1. 0 is included now. How many things can be selected means P plus 1 things. And similarly, second thing can be selected in how many ways? P thing and Q things are there. Number of ways of selecting is 0 or 1 or 2 or 3 or 4 or out of so on. Here also Q0, 1, 2, 3, 4 so on up to maximum is n. Therefore, number of ways of selection of P things are all alike things. Here also alike things. How many ways total number of things are there? Nothing but P things are there, then we can write P plus 1. Why? Because here how many total things are? P things, maximum P things we can select. Here we can select our maximum Q things are select. So 0 is included means P plus 1 and Q is selected means 0 is also Q. So Q plus 1. Therefore total number of ways becomes 2. P plus 1 into Q plus 1. Taken any number of time. Any number of times, total number of ways equal to P plus 1 into Q plus 1. Same thing, just removing the another form, that is the total number of combinations P plus Q things taken one or more time at a time when P of things are alike, Q of things are alike of second kind is one or more time. P things are same, P things are and alike of alike kind of alike, and similarly Q things are alike, but the condition is things taken one or more time, taken one or more time, one or more time. That means the condition, zero condition is not there. Zero condition is not there. That means out of n things, P things, zero condition is not there means it should be anything is 1. So 2 power n is all the condition. If it is not there means you can write as minus 1 thing. Therefore, the number of possible cases are P plus 1 into Q plus 1 minus 1. Why? Because zero consideration is not there. In the same way, P1 things are alike of one kind, P2 things are alike of one kind, Pk things are alike of one kind. So total P things are alike, Q things are alike, and then similarly Pk, P1, let it be P2, not here P2, this should be P3 is there. P3 things are alike, and then so on, Pk things are alike. Then the formula is number of ways equal to P1 plus 1, P2 plus 1, P3 plus 1, so on up to Pk plus 1 things. It is total number of ways. This can be done in total number of combination. This is total number of combination. Number of ways of combinations. It may be 0. But if it is number of combinations of taken one or more time. One or more time means the number of combinations. This can be P1 plus 1 into P2 plus 1 into P3 plus 1 into so on up to Pk plus 1 minus 1. That's all. This is the continuation last. Okay. Last point, Nana. If it is forget. The total number of combinations taken one or more at a taken any number of times is just now we have completed 2 power n. This is 2 power n. If suppose the total number of combinations, here only we can write total number of combinations of indifferent things one or more time. This term is not there. Then it goes to 2 power n minus 1. This is the formula. Okay. First term is not there. Zero selection is not there. Taking one or more time means this value is not there means NC0 1. 2 power n come this side 2 power n minus 1 only. The total possible cases are 2 power n minus 1. Okay. This type of problems tomorrow I'll explain. So practice well, Nana. Inform to your friends. Okay. Tomorrow I will continue. Thank you, Nana. Right.